Next one we're going to do here is the probability of x greater than 130, mean of 100, standard deviation of 10. Okay, we draw those diagrams. On this particular x distribution we have a mean of 100. We're looking for the probability of getting greater than 130, and just like the last example, it's the probability of getting in the upper tail. So we're going to find the z value corresponding to that, and some of you should be able to see that in your head. Alright, so we have 130 is 30 units above 100, and standard deviation is 10 units, so the z is going to be plus 3. Alright, since it's 3 standard deviations, in other words, 130 is 3 standard deviations above 100. But using the formula 130 minus 100, which is your 30, divided by 10, gets you your plus 3. Area of the tail. So just like the last one, this is equal to the probability, oops, not 0 there, z greater than 3, area of the tail, so it's a half, minus the probability of getting a z between 0 and that limit. So let's go to our tables and look up probability between 0 and 3. Okay, and that's 4987. The answer to that is 0013. This next example gets us a probability with 2 limits, mean of 80, standard deviation of 12. Alright, mean of 80. Lower limit is 86, which is above 80. Upper limit 92, which is above that, of course. So the area we're looking for here, probability we're looking for here, is between 86 and 92, some area on the right side of the mean of the distribution. Okay, so we're going to draw the z distribution so that you understand that your two z values are going to be positive, and we'll go from there. Okay, so let's calculate those z values. Z is x minus mu on sigma. The first x, the limit 86 minus 80 divided by 2, and what's that? 6 divided by 12, that's a half, plus 0.5 for the z value. Next one, again, x minus mu on sigma for the z value. The x, the limit 92 minus the mean 80. Alright, there's 12 units divided by 12 units, and that's plus 1. Alright, so this probability that we're asked to find here is the same as getting the z value between a half and 1. Alright, the way we did this in the last lecture was go from 0 to 1 and then subtract out from 0 to 0.5. Okay, so first we get too much, 0 to 1, and then we're going to subtract out what we don't need. What we don't need is from 0 to a half. Okay, go to our tables. 0 to 1 is the 0.3413, minus, and then the area or probability between 0 and 0.5 is 1915. And my calculations, if I'm correct, tells me that that's 0.1498, very close to 15%. Alright, next problem also has 2 limits. The way to figure out what it looks like, the best way is to draw the diagram. Okay, we have a mean of 16, and our 2 limits are below that. We're going from 10 to 15. Particular x distribution. Alright, translate that to the z first in terms of diagram. Alright, so that'll mean that we have two limits on the z which are negative. Okay, and again, some of you should be able to do those calculations in your head, because z is just the number of standard deviations away from the mean. Right, the first limit is 10, mean 16, so that's 6 units down. Standard deviation is 2 units, so that's a negative 3. Alright, so 10 is 3 standard deviations below 16. And the other limit, again, x minus mu on sigma. It's 15 for the limit, 16 for the mean, standard deviation of 2. 15 is 1 unit down, which is half a standard deviation. Okay, so that's minus 0.5. So the probability that we're looking for here is equal to the probability of getting a z between minus 3 and minus a half. And as we do for any probability like this, which is on one side of the distribution, one side of the mean, we take too much, right? The biggest part of the area from 0 to whatever the upper limit is, or the furthest limit is, 0 to 3, and then we subtract out what we don't need, and in this case we don't need from minus a half to 0. We look those up. Okay, and we've sort of looked at all these probabilities before. 0 to 3, 4987. And 0 to a half, 1915. And the probability of works out to be 0.3072 if I've done it all correctly. Okay, this will be the last example like this I'll look at before we go into percentiles. Alright, again we have two limits. Draw your diagram so you get a handle on it. Mean 200, 190 is the lower limit, below 200, 220 the upper limit. Okay, alright, above the mean. So we have an area that goes on either side of the mean. So our first z value is going to be negative, second one is going to be positive. Okay, let's do those calculations. So for the first one, again, x minus mu on sigma, 190 for the limit, 200 for the mean, standard deviation 25. Okay, and that works out to be negative 0.4. And then the other limit, x minus mu on sigma, upper limit 220, mean 200 divided by standard deviation 25. And since that's twice as far away, but on the positive side, let's see if I'm guessing right, that's 0.8. And let me do my calculations off camera. Alright, and that's correct. Alright, so we're looking for a probability on the z between minus 0.4 and plus 0.8. As you saw from the diagram, that's an area that straddles the mean. Alright, we're not going to subtract anything, we're going to add these two things together. So first we go from the lower limit to 0, and then we continue from 0 to the upper limit of 0.8. Alright, so 0 to 0.4, 0.1554, and then 0 to 0.8, 2881, and my calculation shows me that that's 0.4435. Okay, and as I said, that's all the examples I'm going to do for generic distributions. In another lecture we will look at other normal calculations, so we'll get yet more practice if you need some more later.